Sup guys, welcome to today's show. So today we're gonna do something really exciting. We are gonna code our own antivirus program. So basically we are, let me just open this up. So an antivirus, let's say software, a modern antivirus software has basically two different missions. One of them is to scan all the executables on the system for viruses. And how does it do that? Well, it makes a list, of all files, and then selects the executables. So for a Windows system, that would be the exe files, right? And on Linux, it would be the elf binaries. And when we have a list of all the elf binaries or the exe files of a system, then we start scanning them. And we do that by opening the files one at a time, or possibly several at a time if we would do concurrency, but let's keep it simple. And look for virus signatures. So what is a signature? Well, it depends a little bit on the specific virus, but most viruses modify the executable somehow. They add some code that makes the virus duplicate itself and spread, and it will leave some kind of fingerprint behind, some way. So let's say the virus, let's say we have a virus which is called bird flu. And the bird flu virus has some code which in hex looks like this, for instance. I'm just making this up as I go, but let's say that these 3 bytes is in every infected binary with this virus. And this signature on its own, it's not very common in binaries otherwise. So this is a good signature for finding the virus. And what happens when we detect a virus? Well, first of all, we alert the user. We tell the user that a virus has been found, and then we give some options. And these can be different things, but it might be to delete the file or to clean the file if that is possible. And it might not be possible to either delete the file or clean the file, because the virus might stop you if you try. So in that case, you might have to reboot the computer into safe mode and then delete the file or something like that. And this is basically how it works. And when it has scanned all the files, it will keep that in a database somehow, and then it will scan it again after a while, maybe an hour or something like that. And it goes round and round and round, and that way it detects viruses on the disk. And this is the classic sense and what we are going to develop today. But we are also, in maybe a second episode, going to do the second task of an antivirus software, which is prevent the user from, let me make some space, prevent the user from executing a new executable file before it has been cleared by the antivirus software. So basically, if you download a file and you double click on it or // it, or you execute the file, you start the file. The software will intercept the exec call, scan the file if it hasn't already, and then execute the file. Unless it finds a virus, and then it does what it does whenever it finds a virus. And this part is a little bit trickier since we need to intercept every time we execute a file. So basically we need to go into the kernel and modify it somehow. And this can be done through an LKM, which is a loadable kernel module in Linux. That's basically how drivers work. So if you have some new USB hard disk drive or something with a specific driver, then you load the kernel module and you will get access to it. But you can also do other stuff with LKMs. You can basically do everything. You have complete control over the entire operating system in its deepest kernel mode. So that's the next step, developing an LKM which will intercept the exec-v, which is basically, there are a lot of different exec, like exec L and exec V without an E, I think, and a lot of different ways to launch a file, different system calls. But this is the core one. The other ones are basically using this under the hood. So we will need to intercept this call and let the software or the kernel module of the software check if it has already scanned that file, and if not, scan the file or tell the antivirus software to scan the file. And when it's cleared, then we will let this exec call go through. So this will be an interesting part of it. But first we need to create our regular antivirus program. So, well, let's start coding. I want to call this, since we are at the bird theme, I want to call this the bird flu, because whenever a bird gets a virus or something like that, it could be the bird flu. So I think it's a good name. It should be called anti-bird flu or something like that, but that's not as clean. So let's call it bird flu. And I'm going to use bash bs in order to create this. And if you don't have bash bs installed, then you go to the repo. And this is one of the directories which are blue, so you can get it. And bash bs is this one. I have a specific episode about it. And basically it creates a template for a new project. So I'll just do bash bs and I will name this bird flu, like so. And I select the first and only template, which is default C template. And now I have a bird flu directory with the basic files. So basically it's the .c file and the h file, and it's using bird utils and a make file in order to compile stuff. And let's set our home to this. And let's open this in sociopath. So bird flu, open in editor. And we will be able to edit the files, create new files, etc. on the Linux server without having to upload and download and stuff like that. So let's see, I have an empty one here that I want to remove. Let's open bird flu and make file. And I will change this from C2X to C23 since I am running the latest GCC. But if you don't run this latest one, leave it as it is. And we will not touch this make file any more than that. For now, anyway. And the H file has the regular stuff, my aliases for the typecasting and the different integer types. Not much to say about that. So, how do we code this thing? Well, the first thing we need to be able to do is to create a list of all the files in the system. And how do we do that? Well, first of all, we need to be able to check the contents of one directory. So let's begin there. Let's create a function. Or rather, let's start with the data types as usual. That's a good starting point. Because we need somehow to store this data, right? We need some kind of database. Let's see how we can do this. Let's start by defining a structure. Let's call this the database. Or rather, let's begin with an entry of the database. So what should every entry contain? At this point, this will just be a regular file list, not much more. So let's put in here, let's see how we do this. We can have one file and one directory perhaps. So let's say we have a file and a directory. And maybe we can have a bool. No, let's wait with that. Later we will add stuff like when we last scanned it and if it's okay and if it's an executable file and stuff like that. But let's keep it simple now and just do this. And what is a directory and what is a file? Well, let's say that we create a type definition where we say that an int 8 an int 8 directory of size, I don't know, where should we put the limit? Let's say 64 bytes for a directory, because this will have the entire directory structure. And let's say we have 32 for a file. It might not be enough for everything, but let's keep it low. Alright, and let's also make a type definition for our structure. So type def struct sEntry, and we will call this an entry. And when we have an entry, we can define our database. And that will also be a struct, so sDatabase. And the database will contain several entries. So let's do entry. Let's make this a pointer and we'll call it entries. And we also need to know the capacity of this database, how many entries it takes. So let's have an int 16 cap. And we also need to know how many entries we have. So let's call that the size. And this is our database. And then we do a type def struct sDatabase database, like so. Alright. So now we have something to work with at least. And we need something that keeps a little bit of track of this database, so we don't add more than what we have the capacity for, and so on and so forth. So let's start on that end. Let's create something which is, let's say, make database, and it will return a database pointer. Or will it return a database, not a pointer? I think we don't need to make this a pointer actually. So let's say make database, and the only thing we'll give it is the starting point, the number of number of entries we want to have as a starting capacity. So int16 cap. We don't even need to name this, by the way. So we need to be able to create a database. We need to be able to add an entry to the database. So that will be a bool, I guess, or maybe not. We can probably make that a void because it will not fail. And if it fails, everything will fail. So let's call this add to DB. And this will take a database and it will take an entry like so, and yeah, shall we remove stuff? I don't think so. No, let's not. We might want to have a function to destroy the database as well. Destroy DB. And that just takes a database. Like so. I think that's okay. Alright, so let's go. Let's change position of these two, by the way. So let's go to our C file and start with the first one. So we want to be able to make a database, and we want to know the capacity. And how will we do this? We need a local variable for the DB. So let's see. Let's also do an int16 size. And let's see. Well, we can set the DB cap equal to our cap. By the way, will an int16 be enough? We might want to have more than 65,000 entries. How many files do you usually have on a file system? I'm not really sure. Let's count. Let's do something like find slash and just count it. And let's remove error messages. And I guess this will take a while, so let's keep coding while we do. All right, so that's the capacity. We need to allocate the entries. So let's calculate the size of them. So basically it will be the number of entries, which is the capacity, times the size of one entry. So that is the memory we need. So let's allocate that. We need a pointer for the entry. Let's call it P. So P will be equal to the entries, malloc, and the integer size. And we want to zero out p with size. Okay, so now that's done. We have the capacity, we have the, let's also, by the way, assert that the malloc went through. So we have the cap, and the entries will be 0 from start, right? So that is the size will be 0. Maybe is this a good name, size? Let's call it num instead. The number of entries. So we don't mix these up. And now we only have to set the db.entries to our p, and we return our database. Simple enough. But let's try it. Let's create a database. db is equal to make database. And how big should it be? Let's say 50K. 1, 2, 3. I wonder if this GCC version allows me to do this. I want to try at least. I think I read something about C23 perhaps adding support for that, but I'm not sure. So let's see. And then we can print this database. And maybe we should create some function for printing a database, or at least information about the database. So void print, or let's call it show db. Let's make this an int8 pointer instead. Show db, and no. I want to make this void. So show db, and it takes a database. And how does show db look? Void show db database db, and it will simply print the capacity. And it will print the num. And that's basically all for now. Later on, I think I want to be able to print the contents as well, but since we don't have any, let's wait with that. So this will basically be the db cap and the db num. Very straightforward stuff. And then we return. So we create this DB, we show the DB, we destroy the DB, and we return 0. And let's create this destroy function, which is very simple. So void destroy DB, and it takes a database DB. And what will it do? It will set the cap, the DB cap equal to 0. It will set the DB num equal to 0, and it will free all the entries and return. Easy peasy. Let's see if this works. Okay, so on my system I have 221,000 files. Alright, I think we can't manage with an int16. But let's try it for now. Oh, we got errors. Pointer targets in passing, argument 1 of 0 differ in signedness. And I made it, I shouldn't have made it a char. This should be an int8. What else? Okay, I have the old definitions. Let's update them. Because I want the int8 to be 1 byte, this should be 2 bytes, 4 bytes, 8 bytes, instead of the last number of the bits. So let's do this again. Free entries. Entries is undeclared, of course, because it shouldn't be just entries, it should be db.entries. Okay, void should be missing parentheses. Could happen to the best of us. Like so. Invalid suffix. Yeah. It was worth a try. And what's the other one? Implicit declaration of destroy, because it should be destroy DB. And now, ladies and gentlemen, I believe it will compile. Yeah. Alright, let's not do this as root, by the way. And let's run this thing. Yeah, seems to work this far. Okie dokes. So now we have our show DB, destroy DB, and make database. Let's add to the database then. So this will be a void add to DB. It takes a database DB, it takes an entry E. And how does it add to the database? We need a pointer for the entries. And let's by the way, change all this in 16 when it comes to the capacity. This should be an int32, which makes this an int32. And I think that is the only thing here. But inside of the H, we need to change some stuff. The capacity should be 32, and let's do the num32 as well then. And this need to change to 32. I think I got it all. Add to db. Alright, so we need to check first if the capacity is full. So if db dot num is equal to db dot cap. So if you have as many files as we have possible entries in the database, what do we want to do in that case? Well, we want to increase the capacity. And let's increase it in blocks of 50K. So let's first we need to calculate the new size and the new capacity. So the new cap will be db.cap plus 50. Let's do a constant here. Let's call this block size. And let's define this somewhere. Up here maybe. Define block size to be 50, 1, 2, 3. That way we can easily change it if we need to. Okay, so the new size will be the new capacity times size of one entry. How did I do it up here? I typed it like this, but I usually like to do this way without the type definitions. Struct as entry. Only when I do size of. Otherwise I use it. I'm not really sure why. I think I ran into some error sometime, or I don't know. It feels better somehow. I don't know. Alright, so that is a new size. So now we need to realloc this thing. And that's a function I rarely use, but I think we do something like db.entries is equal to realloc, and it shows the order. That's nice. Block and then size. Okay, so block, that is db.entries, and the new size is size. And now we need to update some stuff. We need to set the new capacity to our capacity. Yeah. And let's also assert that we have DB entries, because if realloc fails, we want to fail. Okay, so if the capacity is full, then we just increase the capacity like this. Now we will not have to worry about overflowing this buffer. All right, so let's create this new entry. And that is fairly straightforward. What we need is an index. And the index will be the old cap.num, because if cap.num is that we have 5 files, then the index to reach the last of these is 4, which means that our new one will be 5. So we'll set our index to cap.num, and the next thing we'll do is we want to copy the entry that is supplied to this function to the database. So let's just do a memcopy. And we will copy from entry, and we will copy to db dot entries I, and the size will be size of struct s entry, like so. And we also need to increase the db's num by 1, because now we have an additional entry. And well, that's just about it. Let's return. All right, so let's try this out. Let's create a couple of entries. We'll call them E1 and E2. And let's make it easy for ourselves. As you all know, I don't like to declare a variable and assign a value at the same time. I think that should be separate. But since this function that I want to use, or this functionality rather, doesn't work in C that way, I have to do it. So E1 will be equal to, I want to do like this, so I take one at a time and just do file equals and stuff like that. So file should be equal to, let's call it, I don't know, file1 dot txt, and it lives inside of the directory /tmp, let's say. And that's all for the entry, right? Yeah. And I made these pointers here. I don't think we should. No. So that's entry number 1. 1, 2, 3, 4. So 4dd, paste, paste. And we make another one. It can live in the same directory, and let's call this another file .txt. something like that. So we create a database, and we maybe we can play a little object orientation just to make things a little bit simpler here. Inside our DB, let's add a function pointer. So let's see, add to DB. This will be a void, and let's call it just add. Let's see. I always forget how to do this. Let's see. Void add, and it should take I can't do this without specifying the database anyway, I guess. Let me think a little bit. Can I somehow know where the caller comes from? No. So let's don't do this. It will not be, because if I do it this way, then we will have to do like db.add, and then we will have to put the db here as well, and then the entry. And that's not really gaining anything, right? No. And we can't do it somehow with an alias either, or a macro. Let's see. If we were to do db.add. No, it's not possible. One day I will add this kind of object orientation to C by creating my own pre-processor. But that's for another day. So let's see, we make a database, we add to DB, give the database an E1. We do the same with E2. We show the database and we destroy the database. So let's go through and print the contents as well then. And how can we do that? Well, we need an int32n, and we'll have a for loop where we set n equal to the db's we'll set it to 0, and we will loop as long as n is less than db dot num n plus plus, and at each entry we will simply print. Let's do it like this. So we take the directory and a slash and a space so we can get some separation, or maybe not. We'll just do the file right off. And the first one will be db dot entries n, and this is a pointer So I guess it will be like this. The compiler will yell at us if we make the wrong one here. So, and this is the dir, and then we do db entries n and file as well. I think this should be it. Yeah. Let's see if this thing still compiles. No, it doesn't. A lot of errors. Invalid type argument, have entry, structures entry, db entries, and I guess we should do the dot instead then. But it was a weird error message. Maybe we did something else wrong. Well. It'll work itself out. Or not. We'll make it work itself out. Alright, let's see what this problem is about. Request for member num in something not a structure or union. Cap.num, yeah, it should not be cap.num. Where is it? I forgot the line number. 52. So the ix should be db.num, right? Yeah. Alright, what else? I undeclared, yes, because it should not be I, it should be ix. Next. Incompatible type for argument 2 of memcopy db.entries ix. Yes, let's make use of the reference instead. Like so. Yeah, let's do that. Entry P, unused variable P41. What did we use instead when we allocated? We went directly to, okay, let's just remove this. But it's weirdly many errors. Unknown type name entries. Did you mean entry? Yes, I did. Thank you, GCC. Error. Initialization until char from int 8, blah blah blah, makes integer from pointer without a cast. Makes integer from pointer without a cast. Int 8 star. Right. We did not make those pointers, did we? We made those arrays. Annoying, but yeah, then we can do it like that. Alright, let's do it like we were supposed to, E1, E2, and we will string copy into E1 dot dir. Let's see. Into E1.dir we need to give this a regular string. So file1 dot, no, the directory is /tmp. And let's say the size is 63. We'll do the same with E2. And then we will do similarly to the files. E1.file. This will be file1.txt and the size 31. And then we'll do the same with this file right here, which should be another file.txt. Let's remove this stuff. Alright. And now it compiles. All these other errors were just the same thing. I like it when that happens. Alright, so let's see what happens when we run this thing. That's not what I expected. Why is the num 0? We have done 2 add to db. And then we show the db. And we print the db cap and db num. If db num equals db cap, db num plus plus. That's pretty weird, because we are increasing the num every time we run this add to db, and we are adding to the db twice and then printing it out. So at least the num shouldn't be 0. That is pretty weird. db is equal to make database. Make database return db. Maybe it has something to do with how it is sending those structures as values. I suppose. Because we don't get any errors either. Tricky one, eh? Let's just do some debugging. Let's do db.num is equal to this, db.num db.num is 0, then it goes to 1, and then it's 0 and it goes to 1. Weird. Maybe we should do the pointer stuff instead. I don't really understand this, to be honest. It almost feels like it's a bug in GCC or something, but I don't know. Maybe it's something I'm just not thinking of. Alright, then we need to edit some stuff. Make database should return a pointer. This should be a pointer. So db should be equal to, let's reuse our size variable. This should be the size of struct s database. And we will zero it out. So this will be like, yeah, like this. db size. And before we do that, we need to actually allocate for it. So let's do that. Database malloc, the integer of size. And let's assert that we have a database. Alright. The rest should be pretty similar, but this is a pointer now. So we need to replace the dots. And we return this database, alright? When we destroy it, we need to replace the dots. We need to free the entries, but we can also free the DB itself. And we want the pointer here. When we show the DB, we want the pointer. And same here. And here. And here. A lot of dots. And this will take a pointer. And some dots we need to replace. Maybe we can do some Vim magic. We search the whole document for db and a literal dot, and we change that to db arrow globally. Okay. Where were we? All right. I think the rest is fairly straightforward. Let's remove these for now. And let's update some stuff in here. This will now take a pointer to a database. This as well. This as well. And I probably forgot something somewhere, but let's try. Make database. Yeah. That should be as well. And now it compiles. Alright, let's see what happens this time. Okay, a little bit closer. At least this time the num increased, but now we get empty values here. Why do we get empty values? Because it obviously works when it comes to the increasing. Probably the copying. We shouldn't have the reference here now when we have it as a pointer. Maybe that's just it. But okay, the entries are still right. Wait a minute, aren't we copying the wrong direction? We are copying it to E, we should be copying from E, right? Alright. You need to be careful with it. Now we're talking. Alright, so now it works. Now we can add to our DB in an efficient way, and we will not worry about buffer overflows and stuff. That's good. What's our natural next step? Well, we want to be able to, let's see. We want to list the contents of a directory, and we want to add those things to our DB. Let's start there. So, what should we call that function? It can basically be, let's make it a bool, because it can fail. When we're dealing with I/O, it can always fail. And we don't want the program to crash just because it cannot read one file or one directory. So let's see. Let's just call it add directory, perhaps. Let's call it this for now. Always difficult to name stuff. And it needs a database, and it needs a file path. Let's make it an int8 star. Yeah, that's it. Let's create our function bool add directory. Takes a database DB and an int8 path. And let's make some room. And how do we do this? Well, there is a library call which is called read directory, I think. man3 read dir. This one. And it returns a dir entry. Let me just see one thing. Dir. Get dents man to get dents. What's that? Get directory entries. There is a system call. Maybe we should try that instead. We need an FD DP and count. And what do we get back? inode offset to next dir entry. Length of this, the name file name. Directly -2. Maybe we can use this system call instead. It's a little bit more fun to try new things. I have used the library call every time I've done this before. So let's see, we need to include dir ent.h. Include dir ent.h. And we need, what do we need? We need one of these structures, struct linux dir ent. Struct linux dir ent. And let's see. And we probably need to open this directory first, I guess. Okay, so we just use the regular open system call, but we pass O directory to it. And what do we get back? It's this D thing. D equals struct Linux student buff plus B pause. But do we get back several directory entries or just one? Buff, buff size. Okay, so we get the whole blob of things that they call buff here. And then we parse that buffer as these directory entries. Okay, now I understand. Okay, sure, why not? Sounds like fun, right? Okie dokes. So let's call this P then. And we need a buffer. So let's say int 8 buff. And it can be of size. Before, it wouldn't work any good if we had more than like 512 or something. But nowadays, I think it can handle pretty much. So let's try to read in everything at once. So let's allocate at least, let's see, let's try 100 kilobytes. Shouldn't be too much, I guess. So we need an FD as well. And let's do it like this. Let's do int32 FD. And let's do a signed int ret. So FD should be equal to no, ret should be equal to open. And what do we open? We open the file path, and we want it to be read only, but also O directory, like so. And if this ret is less than let's say less than 1, we simply return false. And if not, we set our FD to be equal to the 32-bit file descriptor. Right, so now that is open. Now we run this call. long syscall. Sysgettance. And it needs an FD as an integer and a buffer. And the size of that buffer. So let's do size of buff -1. Let's, by the way, clean this buffer first. So we'll do 0 buff size of buff, like so, and hopefully we'll get something back. And maybe we should let our ret be equal to this. This, yeah. Let's check the return value. On success, the number of bytes read is returned. On end of directory, 0 is returned. On error, -1. Okay. Alright. Since we're only going to do one read at this point anyway, we don't have to worry too much about the 0. But if ret is less than 0, then we want to close our FD and return false. Okay, otherwise we succeeded. So now we need to parse this thing. Let's create an entry as well, entry E, and we'll do a for loop where we set our P equal to the struct Linux dir ent star of buff. So our pointer is pointing towards the buffer we get back, or the data we get back inside the buffer. And we wanna, let's see, we need to take into account how many bytes we have total. So let me just think. Let's define an int32n, and we will set n equal to the return value, so basically the number of bytes we get back, and let's divide that by the size of one single directory entry. So n basically has the number of files in that directory. So we can iterate as long as n is not 0, and at each iteration we will minus 1 n, and we also want to take p plus equals size of struct linux dir ent. So we basically take one at a time. Think this should work. Let's do it like this. And what to do at each iteration? Well, we want to grab the file name. That's all. So our entry will, let's zero our entry because we're going to reuse it. So we'll do something like this. Size of struct s entry. And then we want to copy into e dot directory, or the char version of that. What is the source? The source is the path, the argument that we send to this function. So let's just do path and 31. And then we want to string copy similarly into e.file, but this time we want to take something else. Now we want to take our p and grab something from p. And what do we want to grab? Well, let's see what we can take. D name is an array. Okay, it's a string basically. Length is actually d reclen minus 2. Okay. So we will copy d name and let's just do 31 here, and not 31 here but 63. So that's the size of that path minus 1. And is it null terminated? Yes, it is, so we shouldn't have to worry too much. And we have a type here as well, but we'll worry about that later. At this point, we just want to grab the file names. And now that we have an entry, we can do add to db, give our db and our entry. And then we will jump ahead to the next file, and next file, and next file. I think this should work. And at the end, we close our FD and we return true because it worked. Alright, this will be interesting. We probably need a couple of more includes since we are executing the syscall directly. I don't think we have syscall. No. Well. Let's see what happens. So how do we test this? Well, we can clean out this stuff. And maybe we shouldn't give any arguments to the make database. Let it use the constant instead. So let's remove this cap right here. Let's search for cap. This should instead be equal to block size. And block size. Let's update our H. Like so. And let's see what happens. We make clean, jump down a little bit, clear the screen, we run make, and boom! Screen full of errors. Who could have thought? Well, open. We need something for open as well. This fcntl.h, which I never seem to be able to remember. Include this thing. And one arrow should be gone. Warning, conversion from unsigned int to int16 changes value. Okay, that's right. Okay, that was a little bit lame of me. The zero function basically can't handle that then. Ugh, annoying. Well. I'll put that somewhere in the back of my mind, and I will use memset instead in this case. So let's see, where is it? Let's search for 0. Here. What we want to do is we want to memset the char version of buff with zeros and size of buff. We did have one more, but this is not a problem. Okay. Good catch by GCC. Invalid application of size of to incomplete struct Linux dir ent. Size of struct Linux dir ent. Incomplete. What's it called then? Struct Linux dir ent. Is that some kind of alias? Like, I don't know, a macro or something? Is that what you mean saying? Could be. Let's find out. It should be somewhere in this dirent.h, I suppose. So we'll go into include and there it is. Linux dirent. Dirent. This file defines struct dirent. It defines the macro dirent have the name len if there is a d name len. Maybe we should go into this directory. Let's search for Linux dirent. Dirent. Struct dirent. But where does the Linux dirent come from? Let's check out that bits one as well. Linux dirent. Nope. Tricky one, huh? This also just defines dirent. Let's do like this instead. We search for everything that contains Linux dirent. Nothing. Struct Linux dirent. Okay, in this example they define it themselves. Looks really weird, all of this stuff. Like it's created ad hoc or something. But let's follow their lead. Let's see what it says. Alright. Warning, point to target passing, 0, different signness. 87. That's right, this should be a 1 right here. What else? P is a pointer. Did you mean to do this? Yes, I probably did. Thank you, GCC. So P arrow D name. Error E1 undeclared. Right, we didn't update this one. So we create a database and we want to try this on some directory. So add directory, we give the DB and let's say /tmp. Let's see what happens. Not what I expected. It got some files, 3, but then a lot of void. How many files are there? Definitely more than that. But it apparently got the number right anyway. But only a few of the files were returned. Let's do this. Assert argc is more than 1. And let's give argv1 here instead. So now it takes directory. In this case we get the make file and then gibberish. So the first iteration is okay. P plus equals size of struct Linux dir ent. And that is the thing we pasted in. But this has a varying kind So we can't really trust the size of that, can we? We need to trust this instead, I guess. Or, this, we have an offset. That's helpful. So let's use that offset. So P plus equals and P arrow D off. I think this should work. No, that certainly did not work. But why does it segfault immediately? We need to recalculate the n as well. Yeah, we can't really do it like that now. Let's do, we set n to be equal to the number of bytes we got from the syscall. And then we decrease n by the offset each time. And we increase p by the same. I think that is the only way to do it. But it's still segfaults. Where does it segfault? We do the get dents, then it segfaults. What about L trace? The string copy doesn't look so good. How many did we get? Get the make file. And then just a lot of gibberish. Little tricky this, huh? D off. Offset to next Linux direct. Reclan, length of this Linux direct. How did they do it in their example? So we have some B position. Starts at 0. B position is less than n read. Okay, n and n read we get from the syscall. So it's this equal to buff plus b pos. And b pos plus equals rec. Okay, they use reclen instead of the offset. Let's try that. Should be the same, but who knows? Who knows? Who knows? Who knows? Where were we? Right. So n less equal d reclen d reclen like so. Let's see if it works now. Right. No, it doesn't terminate at all. N minus equal p d reclen. Let's print some debugging stuff. So p d reclen p d reclen. And let's also print out the offset. This should be off. And finally, the file name as well. And then a new line. Oh, I closed the file. Let's see, here we go. Okay, maybe that's the problem. It's a long int. Let's just comment this out real quick and see what happens if we just change our n to be an int 64 instead. Will that make a difference? It will not. And if we change back to the offset, we still crash. Weird, weird, weird. Alright, so how do we print these values? I think it's LU. This should be S. Okay, so reclan is a regular int, but the offset is a long int. Let's see the head of this. It does get the make file. The offset is incredibly huge. And the reclan is 20. Why is it so big? Okay, so reclan is not even an int, it's a 16-bit. Maybe we should just, for the time being, print out our buff. And then we can analyze a little bit how it looks. So let's do this buff. Let's close the FD and exit. Okay, we can't use printf. We need to do write standard in, standard out, and we will write buff and n bytes. Let's also write some new lines at the end. Alright, so this is what we get. Let's check it out inside of hexdump. We have the make file, birdflu.c. All the files are here. So how big is each of these structures? That's just a couple of bytes we should jump. And how does this structure look? The first thing is an inode. This should be 32 bits, I suppose. Then we have the offset. So 1, 2, 3, 4. This is the inode. And then we have the offset. But how shall we interpret this offset? If we just were to print this out, let's see. As a regular integer, 0f 9b 79 3d. Then we get this huge number. What if we were to do echo this and we mod it to 256? Then we get 61. And from this file name to the next, that's certainly not 69. If we mod it to 65,536, too big. And Let's see, 2 to the power of 32. Even bigger. 1, 2, 3, 4. What about 3? No, that can't be it. Or 61 again. I don't really think this structure is the correct way of expressing it. Linux DRM. What if we were just to use a regular DRM? Would that make a difference? Okay, we're still printing. Well, let's remove that as well. So this. And currently we're using this reclan. Okay, that still has the same problem. And if we use the offset, it crashes. What if we were to use their example program? Will that crash the same way as ours? Let's see if it compiles. Oh. Okay, it compiles. And it actually seemed to work. Could it be that we're using too big of a buffer? But no. Maybe I'm blind, but it seems like we are doing basically the same thing as they are. Buff size 1024. Syscall get done. Buff size. Wait a second. Wait a second. Maybe it has to do with I'm defining P the way I am. But we should be doing byte-wise. So let's do int 8 p2 and p2 should be equal to buff like this. Offset p plus equals, and this should also be p2 plus equals to p d offset. and then we manually set p equal to struct linux drent star p2, something like that. P2 is equal to buff. So it's n, and n is equal to ret, n less than equal to p d offset. Maybe we should do rectlen. There we go. Okay, so that's an annoying little error, but we learned something, didn't we? And I think that's enough for this session. We'll be right back after this. Did you know that I made a book about computer networking? You will learn how the internet works and how everything works under the hood. It's a complete beginner's course, but it has some advanced elements as well. And you will learn network design and network security and all different kinds of stuff. For more info, check out books.drbirch.com. That is books.drbirch.com. Thank you for your support. Alright, you guys, welcome back. So before the break, we managed to list the contents of a directory. And that's all fine and good, but it's not really sufficient, is it? Because what we need to do is we need to be able to differentiate between different types of files, or at least between files and directories. So let's clean this up a little bit and let's see how our database is looking. This is what we have this far. So we have the directory where, well, this file is located. But this file can be a directory on its own, right? So let's create some kind of, let's make an enumeration that differentiates between different types of files. So let's define this as enum file type, and I always seem to forget the syntax of this, but I think it's like this. So let's say file is equal to 1, and what else we got? Directory is equal to 2, and other is equal to 3. I think this will be enough, because this doesn't look right. Let's do it like this. All right. Because other can be like symbolic links and like device drivers and stuff like that. But we don't really care about that. We care about files and directories, and other we will not even well, we will not even put that into the database. So let's do a type definition. Let's type def enum e file type as simply file type, like this. And we'll put it right here. So file type, like so. All right. So let's see. How do we differentiate between different files? We need to take a look at the manual for this system call thing that we're using. GetDents. So the structure we have is this. And we have this char type, which is called dtype, which is file type. So this is the different kinds of files on a Linux file system. And we are interested in this and this, basically. So let's do a check. So first we do this, and then we copy some stuff. So inside of here, let's do an, or maybe we could do a switch. So we switch on the, let's see, on P dtype. And if we get, or maybe we can't do a switch. Let me think. No, because it can be several things of these, I suppose. Which means we have to do something like this. If P dtype and this. Then it's a regular file. And then we want to do this, and this, and this. And we also want to set the file type. So it'll be something like e.type is equal to file. Like this. Yeah. And then we'll have an else if P dtype and dt dir, I think. dt dir. dt, not Dr. Dear. And then what do we want to do? We'll basically do the same. I don't really like to just copy paste code like this, but let's do it for now. Maybe we can make an alias out of it or something later on. And by alias, I of course mean macro. So in this case we do the same, but we set this to a directory. For now. We'll do some other stuff later on, but for now we'll do that. Otherwise, we'll do nothing. We don't even want to add that thing. So we don't need an else statement, I suppose. Alright, and let's see. I stole the bracket from our 4 statements. Now I think it's okay. Why are there 2 steps right here? It's a little weird. Now we're talking. All right, but we still need to do an outer loop because this system call can return a very big directory which doesn't fit in our buffer, even though it's very big. But it can happen. So we need to take that into account at least. Which means that we have to make a loop right here. And we can make it a do loop. And we go down all the way to here. And let's end it by while. I think we can do while true nowadays when we have booleans. And we need to let it jump out again. So it'll be all of this, right? Okie dokes. Looks fine. And so we basically will repeat this until the return value is 0. So else if ret, then we break. Because it returns 0 when all the files have been accounted for. All right. Looks good. So let's make a minor change to our print thing also, because we need to somehow show if it's a directory or not. So let's add a char right here. And then maybe we can do something nifty. Like if db entries and it's n type is equal to directory. What do we want to do then? Well, we want to show an additional slash, right? And otherwise, we just do a 0 here, so nothing. And then we close the printf. Think this will work. Let's see. What do you think about my background? Looks a little bit better than the last one I had. I had real trouble changing it though, because of domain rules and stuff like that. But that's for another story. So we make clean, jump down a little bit. Let's see, is this, no. Clear the screen, run make, and boom. Ha! It compiled instantly. Let's run this on our current directory. And it works. We seem to be off by 1 because we're not listing the first character. That's a little weird. But as you can see, our TMP directory ends with a slash. So we are able to differentiate between files and directories. Let's see if we can fix that off by 1 error. So let's see. We copy E dear. Maybe when we assign the pointer, we should do -1. We need to be careful though where we put the parentheses, because -1 could mean one of these entire structures, like the error we had before, which took quite a long time to solve. But if we link this to this and we put the parentheses here, then we should be fine, I guess. Or am I doing it the wrong way now? What is P? P is a dir ent. Right. So we want the P2 to be -1. And maybe we even can put a parenthesis here just to be safe. Yeah, let's try that. No, that was not the right call. An endless loop, don't we like that? Weird. So let's go back. And let's do it when we copy instead. So we copy from this -1. Or maybe not. Is the directory also? No, the directory seems to be fine. Weird that it's only the file, right? Well, let's try this then. No, wait a minute. I'm far off. I should change this part, of course. All right, let's try again. All right, so now it looks right. Weird thing, but easy to fix. All right, so we also get these two. I don't think we want those. Right. So let's just do a simple check. So if maybe we can create a variable int8 file name. Set the file name equal to p dname, and we need to do this here. And I don't want to make a call to string compare unnecessarily, so let's do an ugly if statement instead. So if file name's first character is equal to a dot, and let's do this. Set the and here, and then we'll do one more level. So something like this. And if file name plus 1 is equal to 0, That's one case. That's the first, that's a single dot. Let's remove these and add them later. So, and this is 1. And like so. So if this and either this or file name plus 1 is equal to a dot, and file name plus 1 is equal to 0. Maybe we don't do equal to 0, maybe we do this. Oh, did I add one too many now? Yeah. So this we do instead. A lot of parentheses. I wonder if I'm going to get this right, but I think so. Alright, so if either, well, this needs to be true. So the first needs to be a dot, and then the second can either be 0 or it can be a dot followed by a 0. And if this is the case, we just move on, do nothing. I think this is right, but I'm not very sure. Oh, point to target. Oh, we need to do this. Comparison between pointer and integer. Let's see. Yeah, I messed up the parentheses here. Still, file name plus 1 is equal to, okay, maybe we need to cast this thing as well. Or this one perhaps. If we cast this to char, and we cast this to a char, we cast this to a char, and we cast this to a char. We should go right. Maybe. Cast to point of integer different size. It shouldn't be, right? But maybe I'm overcomplicating this stuff as I have a tendency of doing. Why are these red? Right, we need that. Is this one too many? And let's redefine this to be a regular, just a regular char. Okay, one error left. Expected identifier before 101 is here. So we have this thing right here. We check if it's equal to, alright, we need to have this, right? No? If file name is equal to a dot, and we have this. Maybe file name is equal to a dot. This is, by the way, not how you're supposed to write code. Comparison between pointer and integer on 102. Yeah, we did the same error here. Okay, I put it wrong. It should be like this, right? This is equal to dot. Suggest parentheses around. Okay. Well, that's only a warning. But perhaps it makes sense. We don't have enough parentheses, do we? GCC want more. Alright, it compiled. Does it work? Please! Because I cannot troubleshoot this thing. Yeah, it does. Who's the man? No, it does not. We got rid of one dot, but not this one. Or I mean 2 dots, but not 1 dot. How can the first fail? That shouldn't be possible, right? It's this. 1, 2, 3. Should only have this. Now I probably messed it up again. It still wants more. I think I will not care about that. Ah, still doesn't work. It's this one that does not work. We have this right here. So if that is, if file name plus 1 is 0, which it should be with only 1 dot, right? or if the same thing is a dot followed by this thing. Screw it. Let's do it like you're supposed to instead. So let's say if one dot file name or two dots file name, then we continue. And then we define aliases or macros. So one dot with one dot with an X and one dot is let's see. So either if, well, X needs to be equal to the dot. That's one thing. The second is X plus 1 needs to be equal to 0. So this is one condition. Two dots. Then X still equal to 1. X plus 2 should be 0. And in between we'll have an X plus 1 that should be equal to a dot, like so. I think this is right. This is a little bit more elegant, isn't it? You should never be lazy when you code. It gets back to haunt you. Called object is not a function or function pointer. Maybe we need to do this. Define two dots X, and if star X called object is not a function or a function pointer. X will be substituted by the file name. If file name and it's only in the two dots case. X plus 1, x plus 2, x is equal to dots. Oh, I forgot this one. Compiles. Will it work? What do you think? No, same problem. The dot. Why? We have if x is equal to the dot, the first character, and x plus 1 should be 0. How can that not be right? It's basically the same code as the two dots. Only that we remove one step of the equation. Am I missing something? Well, obviously I am, since it doesn't work, but you know what? Screw this. I don't want to include hidden directories anyway, so let's just do this. If file name is equal to a dot, then we continue. That's good enough. That's weird. So it doesn't think the first is a dot. Then what is it? Is there some hidden character? And now I got disconnected. I don't like getting hung up on these small annoying things. But it doesn't seem to work at all, because this less history thing is also... Did I even save this? Ah, wait a second. Wait a second, wait a second, wait a second. File name shouldn't be equal to this. It should be equal to -1, remember? Oh my gosh. You always need to remember stuff. And now it'll work perfectly as I wanted it to. Yeah, because now I went back to the first case where I used the hidden directories as well and files. So this is fine. But the dot and the double dot is gone, and that was the important thing. And if I run this on the root for say, yeah, doesn't look so good with the double initial slashes though, but that's only due to how I call the function, I guess. Yeah, because when we do it later on, it will only contain this part. So that's quite alright. Okay, so now we can list one directory, but that's not enough. Because what we really want is we want to be able to traverse the directory structure. So if we find a directory, we don't simply want to add it, we want to go into it and do the same thing again. So we need some kind of a loop, but we don't know how many times we're going to loop, right? Because we don't know how the directory structure is looking, and we might be able to traverse 25 levels or one, we don't know. And when we don't know how many times we're going to loop or what condition will stop it, then it's often, almost always, a good idea to create a recursive function. And the recursive function is a function that calls itself. So in this case, this add directory, if it finds a directory, it will call add directory on that directory. And in that way, it's going to traverse. So we will simply do, if this is a directory, we'll still add it to the database, but we will call ourselves with a new path. So let's no, we need to create a new variable. So let's see, let's create something called tmp of the size, well, we have a max size for directories, so let's use this. And first I want to zero this thing out. Then I want to use sn printf and put into tmp maximum size 63 the current path slash the name of the directory. So that will become our new path. So basically it'll be what's it called? Path. And e dot file. I think that's right. So this is our new path. And now we simply call ourselves. So add dir. We still want to use the same database, but we will use tmp as our path. And I think that's basically it. So what are we going to try it on? We can try it on, I want some directory which has several subdirectories, but not too big of a file system. So this will be okay, I think. Which means we run our bird flu on /tmp. Boom. And it works! Our recursive function works out of the box, ladies and gentlemen. Isn't that fabulous? Look at this. Beautiful. It's like a piece of art. Alright, so now we can traverse the entire file system and we can add stuff to our database. Pretty nifty. Pretty nifty. So when we have an entire file system inside of our database, what's our next step? Are we interested in all these files? No, we certainly are not. What we are interested in are executables, right? And in Linux, there's only one type of executables, basically, and that's ELF binaries. So if we look at bin ls, for example, and we do a file on bin ls, it'll say it's an ELF binary. There are different types of ELF binaries, but they all have in common, if we do a hex dump on bin ls and watch the top of it, it begins with this. So basically, these four characters. So we need to check every regular file on the file system if they are of this, and in this case we will keep it in our database, otherwise we'll throw it away. So we need to create some kind of a filter function. And I want this filter function to be what's the word I'm looking for? It can be parametric or ad hoc. Sometimes my brain just freezes. Well, I'll come up with the term, but what it means is we want to be able to handle different types of filtering logic, basically. So I want to create one filter function, but I want to be able to use it for filtering with different conditions, right? Right. So let's define a function pointer type. Let's say a function is something of type bool, which takes an argument of type entry. like so. So we need to define the entry before we do this. So let's put this on the bottom instead. Like so. And what's the signature for our filter function? Well, it will return a new database. So we'll give it a database, and it will filter that database and return a new one and destroy the old. So it will return a database pointer, filter, and what will it take? Well, it will take a database, an input database, and it will also take a function. And that function will be applied to all the entries in the database, and if it returns true, we'll keep it. If the function returns false, we'll throw it away. That's the general idea. So let's see if we can code something like that. Let's put it on top. So database, filter, database DB. Maybe we should call this input. And then we have the function f. We also need to have an outer database, output, and we'll set output equal to make database, like so. And we need to have an entry pointer, do we not? Yeah, I think we do. Entry P. And we need to have a loop to traverse our database. So basically we will do something like this. A for loop where we set P equal to no, we need to have an integer as well. In 32n. So we'll do for, and we set n equal to 0. And we're going to go as long as n is less than the input database num and n plus plus. Maybe we don't need this entry thing. Or let's keep it. It makes the code a little bit more readable. We love readability, don't we? So at each point in the input database, we'll set P equal to input entry entries and n. So this is our current entry. Then let's create a bool which we will call predicate. And predicate will be equal to a function call to the f function, and we give P. Do we not? do we give it P like this, perhaps? Let's try that. And if predicate returns true, so if whatever this f function does returns true on that entry, then we want to take our output database, add 2db to our output, and we'll take our entry and put it there. And if it returns false, we do nothing and just continue. And at the end, we destroy the input database and we return the output one. So this is the general idea. And let's try it by creating a test function. So we'll do bool test function, and it takes an entry. Did I say entry star or just entry? Just entry. So entry E. And let's say we return if the entry's type is equal to file, say. Then we return true, otherwise false. So we will only keep the files, not the directories. And that is just for test. So let's create a db2. Because when we code this way, we can reuse that filter function to a lot of different things. We can test if if it's a file, if it begins with the elf magic string, or if we have scanned it for viruses before and stuff like that. So we can do a lot of different things. So we add this directory. Then we set db2 equal to filter. And what do we give filter? Well, we give it the db, and we give it the function test fun. And then we show db2 instead and destroy db2. Maybe we should, let's do it like this, see if it works. And I got disconnected again. My wireless is not with me today. So let's see. Intel 32, Intel 32. Compiled, right? So let's run it against our TMP, and this time we should only see files, no directories. Did not work. That's a bit weird. Maybe we got disconnected here as well. Yeah. apparently from the VPN as well. I'm glad that Sociopath is resilient, so even if we get disconnected and reconnect, all the files should sync if we just resave them. Okay, we got an error, right. All those dots and arrows. So let's see, that should be inside of the filter function. This should be like this. All right. P equals input entries and so what is it saying here? It is complaining that I'm pointing a pointer towards something. Maybe it wants this. Or can we do this perhaps? I'm not really sure. Let's try it. No, I can't do that. But I guess this is the same thing. Error incompatible type for argument 2 of add2db. P. Right, that should also be like this. Compiles. And it seems to work. Pretty nifty. Let's try the opposite. So if it is equal to a directory instead. Yeah, now we see the directories. Quite nice function, huh? All right. So let's create a function like this test fun, but instead of testing if it's just a directory or a file, we want to check if it's an ELF binary. So let's create a new function. Bool. What are we going to call this? Is ELF, perhaps? And it takes an entry E. So first of all, we want to check if e dot type is not equal to file, we can return false directly, because we're only ever interested in files at this point. But if it is a file, we need to open it and check its contents. So we'll need a file descriptor, and we will let's keep it like this and do a signed ret instead. So ret will be equal to open, and what are we going to open? The char version of e dot. We need the whole path name. So let's say path. We want to open it as o read only. But we first need to create that path. So let's do it like we did it before. Yeah. So let's create int 8 in path size 64. And before we open, we zero out our path. We do an sn printf, and into path size 63 we want this, where the first is e dot directory and the second is e dot file. That constitutes the path, right? And then we open this path. If ret is less than 1, then we can return false. Otherwise, we set the fd equal to ret, like so. Alright, so now we need to open, now we need to read the first 4 characters of this thing. So let's create a char buff for size 4. Let's zero out this buff. Then we read into buff. Let's see, read from the file descriptor into buff 4 bytes. Then we can close our file. And then we'll do one of these wonderful if statements again. But this time it's a little bit easier. So if buff 0 is equal to let's do this hexdump thing again. equal to 7f and this is equal to 45. Let's do something like this, and 1 and 2 and 3, 40, 46. If all this is true, we return true. Otherwise, we return false. Alright, I think this is a good enough function. Is elf. Let's create a signature for it as well. So we have a bool is elf, which takes an entry. And let's test it out the same way we did before. Let's remove this comment. And let's just change this test fun to is elf and see if we can do this. So if we look inside of our TMP directory, do we have any elves there? No. Let's copy a couple of elves there. So we can take the ls and why not the copy command itself. And we copy it to the temp directory. And now we have those two there. And let's move the ls1 into the GHC folder so we see that it works recursively as well. I think this should compile. Yes. Alright, moment of truth. It got the ls but not the other one. That's interesting. That's really interesting. Extent. So we have these four, and we compare it to PMP, GHC, LS. And we have these four. Are they the same? They are. So why didn't we get that other one? What if we put a third in there? LD into TNT. We'll run it again. Okay, it got those two, but it does not get the CP. Is it? No. Why is that? it something special with that file, or is it that we are off by one again when we traverse or something like that? Well, let's remove CP and let's copy the move command instead, and we'll put it in the same directory. We'll run it again. This time it got them all.